Hi, so this is a quick software demo of what we've been working on over the past year. So I'm going to run through what the features we have in the software now are currently, but also, if you see anything that you think would be helpful to add, we'd love to get your feedback, because really just trying to make this as easily usable for the practitioner using it, to be able to pull data and see, and make decisions based on it. So if there's anything, feedback you can give us, features you'd like to see added, or things we may not have considered, please let us know, and we'd be happy to chat some more about it. So first, we want to click the Load Data button, and we're going to load in 3 different scans. So we're going to load in scans 1, 2, and 3. And so these scans are from the Yellowstone Club, which is a ski area not too far here from Bozeman. And they were nice enough to let us go up throughout the winter and take scans of one of their ridges at the ski area. So then we had basically data to practice with and run tests on. So once you've loaded in the scans, you want to then pick what your ground, intermediate snow, and new snow designations are. So what this is going to do, the reasoning, there's these 3 designations is your new snow will have a snow depth calculated to the ground, so basically a total snow depth, and then also your new snow will have a snow depth calculated to the intermediate snow. And the reasoning behind this is if there was a mid-season storm, storm could have been a few weeks ago, storm could have been a week ago, you want to see the accumulation after that storm, because you're worried about it having formed a layer or something like that. We can easily then have that data readily accessible as well as your total snow depth for that scan. So that's the reasoning behind the intermediate snow scan and the ground snow scan. So once we've loaded them in, we want to click this Find Vegetation and Cliffs button. And so what that's going to do, it's going to take those 3 files, take their point clouds, and then basically look at them. So say you take a scan, you're looking down on it from up above, like a top-down view, and you can see your XY coordinates. So we're going to take those XY coordinates and grid them up. So basically we're going to take this and put a grid on top of it. And so what that does is once we grid it up in the X and Y, we can look at what the height change is within that grid cell. And the reason we're doing that is we look at the height change to see, all right, is this change in height corresponding to a slope angle of 60 degrees or not? And what we said is that anything above a 60-degree slope angle is most likely not a slope, not a slope that would slide too much or have much accumulation. It's therefore most likely a tree or a cliff or something like that. So basically anything that's below a 60-degree angle is considered, good for a snow depth calculation. Anything above 60-degree angle is considered trees or a cliff. And so that's where we're getting, so that's where the 60-degree comes from. And so once it's done that, and then you can, it prints out some stats here, and it'll tell you that the ground scan had about 9,300 cells with vegetation, intermediate snow scan had about 2,600 or 26,000, and then the new snow scan had about 20,000 cells of vegetation in it. And so once we flagged the cells of vegetation, we then calculate the snow depth. What the snow depth then does when we're calculating the snow depth is it goes into each of these grid cells and compares the average depth of the new snow scan, the average depth of the intermediate snow scan, average depth of the ground snow scan, and then calculates your average heights, and then calculates your snow depth based on that. So the reason we want to flag the cliffs and vegetation is that we don't want those being factored into our snow depth calculation, because if a tree is 20 feet tall and your snow depth in the slope next to it's 5 feet, that's as you're looking at your averages and looking at things on the map, that 20 feet wouldn't be applicable to trying to figure out applicable and comparing it to that 5-foot slope to the right of it, right? So once we've found the vegetation, we're going to calculate the snow depth. So then you can see here that we had a depth of about 5 feet to the ground scan and about 2.5 feet to the intermediate snow scan. So first let's plot it with respect to the ground scan. So when we do that, we'll talk through this plot a little bit real quick. So the green coloring in this is what has been flagged as trees or cliffs. And it's made a bright green. It's super easy to see. Just a couple things here is, these higher density greens where it's like the point density is higher, those are your treed areas. And then the lower density are your cliffed areas. I think just based on the branches and everything else in the trees, it makes sense that you're going to have a little bit higher point density in those areas, making it kind of show up a little bit more versus having just kind of this reflection off the cliffs. And so then the other thing is the shading in this plot. So with the shading, positive changes in snow depth are shaded red, and negative changes in snow depth are shaded blue. So in this one, we only have positive depth changes, and if there's no depth change, if there's no depth change, it's basically white or gray. And so with this one, you can see on the edges here, that sharp line, that's just corresponding to where the scans stop overlaying each other. So for instance, you can't calculate snow depth if the scans aren't, there's not a scan area there. So basically you're just seeing where the extents of one of the scans ends at these points. And so you can see here, deeper red for higher snow depth, and then lighter red in this area for less snow depth in that area. And yeah, your median color is 0. So if there's no snow depth, median color is white. So if there's no snow depth, it'll kind of be a whiter gray color. And so then, if we want to look at the other snow scan, the intermediate snow depths, we'll plot that. So yeah, and what you can see here is a little more variability in your snow depth. So here, darker red, it's a deeper depth. Here, lighter red, not as deep of snow depth in this area. And so one of the features we added into this to try and allow better visualization is this upper bound. And so what that does is, if I put in a depth of 0.5, this is in meters, not feet right now, but in a depth of 0.5, what that means is that that's going to be where your color scale will max out at. So anything above 0.5 meters in depth will be your darkest, brightest red color. And then it'll basically scale it down below that. So then you'll have like some basically white to red scaling between 0 and 0.5. And anything above 0.5 is your darkest red. So we'll replot that. And so now you can see where it was lighter over in this area, we're now basically a dark red. So you're seeing like where that is either 0.5 meters or deeper in a lot of this area. And so then another cool feature that we added in is this ability to select points. So if we click this button, your default select will be this rectangular box. So say for instance, I want to know what the snow depth is like, in this area right up here. So I can draw this rectangle right there, and it'll color it pink to highlight those points, and then also it'll tell you that in that area you had an average depth of 2.5 and a max depth of 3. So the other thing we wanted to do is, while a rectangle is good, what if there's like a custom area that we want to know the depth of? So while you're still in this selected point, so I said it's still clicked, if you press the number 1 on your keyboard, it'll swap your select mode to basically a lasso or a more customizable selection mode. So you're going to click your mouse and then you can draw exactly the area that you want the snow depth of. So if I want it through this entire kind of chute right here, I can draw around that. And it'll highlight it pink, and it'll tell you that the average depth of that entire area was 2.07 and your max depth was 3.77. So adding in the selection, we wanted to try and basically give whoever's using this the ability to pull out specific areas of data within the scan. So if you know an area is a problem area, you can easily go to it and say, all right, hey, I want to get the snow depth in this area, and you can easily pull that data and make decisions based on that. So this kind of concludes the demo. Like I said, if you have any feedback or any questions, feel free to reach out, and we appreciate it. Thank you.